real good day in algebra. We'll be covering PO3, our first power objective of the year, which means it is very important to learn this. Adding and subtracting rational numbers. Of course, that phrase rational numbers, like we've talked about, includes those integers and decimals and fractions, all of which you have had before, save for maybe subtracting a negative. Have you seen something like that before where you're subtracting a negative number? Fantastic. Then it's all going to be review for you, okay? But it is that important that we are comfortable with this in algebra that is represented as a PO in this unit. So starting with integers, let me scroll down a bit here. Pen is down. That's good. And we go like this. You'd think in week 3 I would have this down, but nope, I don't want to cut anything. I don't want to. Okay, very good. All right. Do you folks like make fun of me at home to your parents behind my back about how I can't do the scrolling? Okay, thank you for that. Thank you. So with integers, these are the non-decimals, the non-fractions. This is what you learned back in kindergarten, first grade, second grade, just simple addition and subtraction. But now that we'll be dealing more with negative symbols and negative values, we just want to make sure we're all on the same page. So when you add a negative, okay, adding a negative number, what's an example down here that you can see of these? How many are there? 18 of them? Of these 18, what's an example of adding a negative number? Yeah. 14 plus negative 3 is an example of adding a negative number. What's another example that you see here? Adding a negative. Yeah.
Negative 7 plus 9.
Negative 7 plus 9 is not adding a negative, and we'll talk about why that is. Because, I mean, it looks like it should be, right? You see the negative, you see the positive sign there, but it's not actually a case of adding a negative number. We'll talk about why. But what's in the back?
12 plus negative 15.
12 plus negative 15 is an example. What's another one? Negative 25 plus negative 8. Now, what do all three of those have in common that this one does not? Yeah.
You're adding a negative, not adding from a negative.
Okay, so look at what's in between the numbers, right? Plus negative 3, plus negative 8, plus negative 15. Here, all we have is the plus sign. The sign of the number that you're starting with has nothing to do with the operation. Nothing. All it means is where on the number line you're beginning. Here we're starting at positive 14 and we're adding negative 3. Look at what's in between. Starting at negative 25 and adding negative 8. Look at what's in between. Okay? So that is the difference there. So what operation is it really? When you add a negative, what operation is that? Addition or subtraction? Yeah. It is subtraction. And whenever we are subtracting, which direction do we go on the number line?
Down or negative.
Negative or left. Okay? Number line goes left to right, left. And the examples that we have here, we've got 3 of them. We'll take the first one here, 14 plus negative 3. What answer would that be? What is 14 plus negative 3? Yeah.
12.
Try again. You went the right way. Just didn't get the right answer. 11. Essentially 14 minus 3, which is going to be 11. Okay? All right. How about when you subtract a positive? Give me an example here of subtracting a positive of the 16 below, 18 below. What is subtracting a positive? Yes. 5 minus 3 is subtracting a positive. What's another example? 12 minus 20 is subtracting a positive. What's another example?
0 minus
0 minus 4 is subtracting a positive. What's another example?
Negative 7 minus 19.
Negative 7 minus 19 is subtracting a positive. What's another example?
Negative 42 minus 7.
Negative 42 minus 17. What's another example? There's a lot of them up here. Yeah.
Negative 13 minus 8.
Yes, good. These are all examples. Here's another one here too. These are all examples of subtracting a positive number, okay? Because regardless of whether our first number is positive or negative, again, look at what's between. Minus 6, minus 20, minus 3, minus 6, minus 4, right? Doesn't matter if we're starting at negative 13 or 12. That negative sign in front of that 13 has nothing to do with the operation. Okay, so subtracting a positive, what operation is it really? It's subtraction, which means we're going left on the number line. So an example such as negative 13 minus 6, what's that value? Negative 13 minus 6. We're starting at negative 13, and we're moving left on the number line 6. Yeah. Negative 19. Very good. Okay. Starting at negative 13, going to the left 6, we end at negative 19. All right. I'm going to try and erase fast here by doing this nifty little... Sweet. All right. The next thing would be adding, or just add, stay consistent here, add a positive. Give me an example here of adding a positive from our 18 below. Yeah, Joey.
Negative 7 plus 9.
Negative 7 plus 9 is adding a positive. That sign out in front of that 7 doesn't make a difference. Yeah.
Negative 9 plus 9.
Negative 9 plus 9 is adding a positive. What else? Yeah. Good. Negative 15 plus 31. I just so happen to put only, we're adding a positive. The starting number is always negative, but that's okay. Okay. But yeah, those are the 3 examples there. And what operation is that when you add a positive? Addition, which on the number line means we're going to the right. Since addition is the opposite of subtraction, it makes sense we'd go in the opposite direction on the number line. An example here, let's take negative 7 plus 9. We're starting at negative 7. We're going to the right 9. What number do we end at? What is negative 7 plus 9?
2.
Positive 2. Positive 2. Okay. If you're thinking, wait, isn't negative 7 plus 9, wouldn't that be negative 16? Right? Because 7, no, right? If you think of a number line, negative 16 is to the left of negative 7. But our operation indicates we're going to the right. Okay, so really be thinking about where am I starting, which direction am I going. Lastly, subtracting a negative. Whoa. What kind of sorcery is this? There we go. Whew. The ghosts of math teachers past coming through. Subtract a negative. Okay. What's an example of subtracting a negative here from these 18 that we have? Yes?
13 minus negative 4.
13 minus negative 4 is subtracting a negative. What's another example?
4 minus negative 5.
Negative 4 minus negative 5 is subtracting a negative. Yeah. 22 minus negative 18. Any more? Both are right. Yes. 13 minus negative 13 and negative 5 minus negative 20. I think that's all of them. Okay. Can you guess which other type here is most confused with subtracting a negative? Because maybe either you've done it before or just kind of can predict. It's actually subtracting. It's one like that. Negative 13 minus 6. Where you see the negative sign with a 13, you see the negative sign with a 6, and your brain goes to, oh, 2 negative signs, subtracting a negative. And that's where, like I've been saying, I'm really going to hammer this home. That sign of the first number has nothing to do with the operation. Always look between. Minus negative, minus negative, minus negative, minus negative, minus negative. Okay? Look between the numbers. In what operation would subtracting a negative actually be? Addition. Why does that make any sense? Subtracting a negative is addition. Well, those of you that are lit people, you've probably heard that, you know, the whole double negative thing. A double negative is actually a positive, right? If I'm not happy, well, I'm not happy, that means I'm happy, right? Kind of what's going on here. Subtracting a -4, those two negative signs actually make the operation positive. So we're adding, which means we're going to the right on the number line. An example would be -5 minus -20, which is actually -5 plus 20, which is a value of what? Positive 15. We're starting at -5. We're going 20 to the right, past 0, into positive territory, and we end at 15. Okay? Questions on integers? I probably spend more time than I needed to on them, but that's okay. I'd rather spend more time than not enough time. So we're good? All right. Moving on to decimals. What's the biggest thing to remember when adding and subtracting decimals? The thing that you probably did wrong, like I did when I was first learning how to add and subtract decimals so many years ago. Yeah, Caleb. Line up that place value, right? Line up that place value. 7.1 plus 12.6. It's not going to be, well, 7.1 and then 12.6. Okay, that's not going to work out, right? Because you're adding what's in the tenths place, that 1, to what's in the ones place, the 2. That's a problem. Okay? 7, which is the ones place, into the 1 here, which is in the tens place, that's a problem, right? So adding and subtracting, I don't think we need to spend much time on this because it's weird. The algorithm is just, align place values, add vertically, do your carrying and your borrowing and all sorts of things there, but just make sure they are lined up. Make sure they're lined up, okay? How would you go about that third one there? That one looks a little bit tricky. -3.65 minus 14.12. Talk me through any ideas you have for that one. Yeah, go ahead.
Just add them up and then take the negative side of it.
Are you telling me that -3.65 minus 14.12 is the same thing as positive 3.65 plus 14.12, but then when you're done, you just make your answer negative? Why does that make any sense? Go ahead.
Because you're going left on the number line, and if it's already there, then you're just adding to it.
Sure, I follow that. Yeah. So let's think about number line here. Okay, zero's in the middle, right? Got positives to the right, negatives to the left. If we're starting here at -3.65 and we're subtracting, so we're going left 14.12, isn't that kind of the same thing as starting at positive 3.65 and adding 14.12? Right? Because we are starting a certain distance away from 0 and then going an equivalent distance further. So 3.65 plus 14.12 is 17.77. Being -17.77 is the same distance away from 0 as positive 17.77. So if it's easier for you to think about it in this sense, I'm starting 3.65 away from 0. I'm moving 14.12 further. I'm ending at 17.77. It's the same thing on the negative side. Okay, so just don't forget to add your negative sign back in when you're all done. Does that make sense? Kind of what's, yeah, okay. Thrilling, very good. Did I see a hand up go over there, possibly? No, I'm old, okay. Anything else with decimals? All right, everyone's favorite, save the best for last, fractions. What is that thing that you must remember to do when, adding and subtracting fractions? Miranda. Sorry? Shh. Yes, those common denominators. Common denominators. 2/12 plus 7/6 is not equal to 9/18. Right? When you think of a denominator, think about it as a thing. Okay? If you have, let's say that instead of twelfths, we were talking about chairs. So we have 2 chairs. And we have, instead of sixths, let's say that's tables. 2 chairs, 7 tables. Can you combine those to get 9 tables? 9 chairs? I mean, how could you combine a chair and a table? It doesn't work. They're not the same thing, right? Denominators, that's kind of what's going on here. You can't add twelfths and sixths because they're not the same. My son wants to grow up to be a zookeeper. And when I say grow up to be a zookeeper, he told me that when he's 7, he's going to ride his bike to his zoo and be a zookeeper. Okay, he's currently 4, so we'll see what happens there. But anyway, if you're a zookeeper, you're not going to add like pandas to the lion cage, are you? That's not going to end very well, right? You know, you don't combine things that are not alike in that sense. So that's what's happening here. So as you've been preached to many times before, I am sure, since we can't add 2/12 and 7/6 as they're written, what do we need to do instead? Yes. We have to find that common denominator, which in this case, based on how these fractions are written, we can either bring that 6 up to a 12, or, because 2/12s can be simplified, we can bring that 12 down to a 6. Which one would you rather do? Which one sounds more fun? Yeah. Perfect. And how do we do that? Okay, so we're going to divide both 12 and 2 by the same thing, in this case 2, to bring it down to 1/6. 1/6 and 2/12 have the same value. That's why we can do it. If you take a calculator and take 2 divided by 12, and then 1 divided by 6, you get the same exact decimal. They have the same value. But now we can add 1/6 and 7/6. We can add 1 chair to 7 chairs, 1 lion to 7 lions. It works. And when we do that, our denominator, what? What's the second rule? Denominators have to be the same, and they have to, anybody? Stay the same. Because if you do add 1 lion to 7 lions, you don't get 8 mega lions, right? The lions don't transform into something different. No, it's just, you're still talking about sixths. I've got 1 of something, I get 7 more of that same something. I now have 8 of that something. 8/6. Okay? And then the third thing we have to remember when adding and subtracting fractions is that when we do get our answer, we also must simplify. Okay? Never ask me if you need to simplify your fractions. You would never ask your lit teacher, so when I'm writing my essay, do I have to end my sentences with punctuation, period, question mark? Is that something you want me to do? Of course it is. And I want you, it's not different at all. No, always simplify fractions. It's just what you do. Okay? So 4/3, dividing 8 and 6 each by 2, to get 4/3, that would be your answer. If you're more of a mixed number person and you want to write your answer as 1 and 1/3, that is fine as well. The only thing I'm going to say about that is that as you get higher into the maths, you use mixed numbers less and less and improper fractions more and more. So if you've always been an improper fraction person that has been told to convert to a mixed number, you don't have to anymore. Okay? If you want to, it's fine, but we are going to use improper fractions more frequently. Okay? There you go. There's my spiel on rational numbers, adding and subtracting. Any questions, comments, concerns, complaints, compliments, or criticisms from you?
I don't think you said congratulations.
Yes, I did actually. Questions, comments, concerns, complaints, compliments, congratulations, or criticisms.
Congratulations.
All right. Any you want me to go over from anywhere on the assignment page, PO3? Any that look particularly fun? You want to share the experience with the class? Yeah.
2 and 5 ninths minus 1 and 9.
Oh, 2 and 5 ninths minus 1 and 9 tenths. So if you are given an improper fraction, if you are given a mixed number, my recommendation would be to convert them each to improper fractions first, and then do your calculations, the common denominator, simplify, do all that stuff. So as a brief review, how would we convert 2 and 5 ninths to an improper fraction? Joe? And how would you get that? 23 over. Sure, that shortcut that you were probably taught was multiply the denominator by the whole and then add your numerator. Okay, 9 times 2, 18, plus 5 is 23, so 23 ninths. What's actually going on here is, at 2 and 5 ninths, we have 2 wholes there, right? That's what the mixed number tells us, how many wholes we have. We have 2 of them. How many ninths make up 1 whole? How many ninths would make up 1 whole? 9 of them. So if we have 2 wholes, it's really like we have 9 ninths, that's 1 whole, plus another 9 ninths, there's our second whole, plus the 5 ninths that we have as our part. Now adding fractions, the denominator would stay the same, we just talked about why, but 9 plus 9 plus 5 is 23. Okay, so that's mathematically why that shortcut works, because you're multiplying how many ninths you have in 2 wholes rather than just adding them up here. Okay, that's why the shortcut works. So anyway, we got 23 ninths, and then minus 1 and 9 tenths as an improper fraction, that's 19 tenths. And now you can get to work getting your common denominators and doing your subtraction. Okay? Anything else? Okay. Your assignment for tomorrow is to finish PO3. You've got about 10 minutes to work on it now. Make sure you are writing your answer in simplest form. Feel free to use a calculator to check your answer. You will not be able to use a calculator on this section of the test. So just remember that. And that, folks, is how you math.